Welcome to Severstal Dearborn, one of the world's legendary steel-making facilities. Situated within an iconic integrated industrial campus, conceived and built by the visionary Henry Ford over a century ago, Severstal Dearborn enjoys a long-standing history of steel innovations dating back to the nation's earliest days of automotive manufacturing. Today, the mill is an impressive operation unto itself, beginning with a new state-of-the-art blast furnace, operating 24 hours a day, year-round, to produce 6,000 tons of molten iron per day, and continuing through advanced cold rolling and galvanizing facilities. Dearborn even features its own railway to support the considerable logistics of the extensive facility. With investments of more than $1.6 billion since 2007, the mill has truly been reborn into one of the most modern and efficient steel-producing locations in North America. This modernization has vastly increased Dearborn's capability to produce a broader spectrum of sophisticated, advanced steels to meet the most critical, demanding applications. Severstal Dearborn's steelmaking process begins simply with 1.8 billion-year-old iron-bearing rocks and 350 million-year-old coal. Iron ore from Michigan mines and coke converted from West Virginia coal are transported to the mill by rail and freighter and moved to the mill's C blast furnace. Rebuilt in 2007 with the newest available technologies, the furnace is one of the world's most efficient, productive, and environmentally friendly. While the iron ore and coke, along with limestone, are conveyed into the top of the furnace, superheated air is blown into the bottom, elevating the furnace temperature to 4,000 degrees Fahrenheit and creating chemical reactions which form molten iron. Technicians carefully control and manage the operations from a highly automated control pulpit, Mission Control for blast furnace operations. A robotic arm drills out a clay plug, causing a spectacle of cascading sparks, and the furnace is tapped. The molten iron flows into insulated bottle cars, which are transported via the mill's own railway to the next operation, steel making. At this point, the molten iron is not yet steel, so the contents of the bottle cars are poured into huge ladles and carefully transported by overhead crane to the basic oxygen furnace, or BOF, where the steel making begins. Before the molten iron is poured into the BOF, a load of scrap metal, a natural byproduct of the area's many automotive processing plants, is added for a mix of approximately 25% scrap and 75% molten iron. Pure oxygen is then blown into the mixture at more than 21,000 cubic feet per minute, removing the carbon, melting the scrap, and creating steel. The BOF vessel's molten steel contents are poured into a ladle capable of carrying 250 tons and brought to the LMF, or ladle metallurgy facility, where precision chemistries are produced. Electrodes are lowered into the ladle and the liquid steel is reheated while alloying elements are added to achieve the chemistry required by the customer. The process controls the chemistry, cleanliness, and temperature of the steel. Depending on the specific requirements of the steel, the ladle may be transferred to the neighboring vacuum degasser, which can produce ultra-low carbons of 0.01% and below. This process involves exposing the liquid steel to near absolute vacuum to produce steels with superior formability and increased strength to meet demanding applications. The next stop is casting, where the ladle is carried to one of the mill's two rotating turret continuous casters. The liquid steel is poured through a refractory shroud to an intermediate vessel called a tundish. As the steel flows downward from the tundish into the caster, water-cooled copper molds reduce the temperature and the steel begins to solidify into a solid block known as a slab. At the bottom of the copper mold, the 8-inch thick slab is further cooled by a fine water mist, and gas torches cut the slab to a length required by the customer order. The glowing hot slab is bar-coated before its journey continues to the hot mill. The huge slab, which can weigh more than 63,000 pounds, is heated to more than 2,300 degrees Fahrenheit, making it pliable for rolling and hot reduction. As the glowing slab leaves the reheat furnace, it first enters a scale breaker to knock off the scale from the surface before continuing to the 4-stand roughing mill, where the 8-inch thick slab is reduced to 1.5 inches. As the red-hot slab leaves the roughing mill, it enters the 7-stand finishing mill and is reduced further to the ordered gauge, as thin as 0.070 inches. A slab 33.5 feet long can become a coil of steel about 4,100 feet long in a matter of minutes. The ribbon of steel continues over a runout table, where the steel is cooled with water sprays programmed to create the specific physical requirements of each order. With increasing velocity, the red-hot steel arrives at the hot strip mill's down coiler, where it is rolled into huge coils before exiting the mill, banded, and robotically marked for accurate tracking. These hot-rolled bands may now leave the plant to be used to manufacture a wide variety of products, or they may be further processed downstream into cold-rolled or coated steel products. To produce cold-rolled product, the hot-rolled band is transported to the pickle line tandem cold mill. Launched in 2011, Severstal Dearborn's PLTCM represents the most cutting-edge technology of its kind, adding new precision and quality control to the cold rolling process. The coils are moved into the PLTCM on an automated materials handling system, reducing the potential for damage and maintaining coil identity. The automated coil preparation station safely removes the bands and optimizes product yield by only cutting off the necessary portions. The coil is then lifted to the PLTCM. The PLTCM thoroughly removes all scale from the steel before it enters the 5-stand, 6-high mill. Advanced universal crown technology enables a wider range of product thicknesses and widths, and precision products from ultra-low carbon to advanced high-strength steel can be produced. A strip surface inspection station enables comprehensive surface inspection under tension without disrupting processing. The exit coil handling system automatically bands, marks, and applies barcode tags to the finished coils. At this stage, the coil is now a full hard cold-rolled product. Depending on the order requirements, the coil may require annealing, a process where coils are stacked in a hydrogen atmosphere furnace to soften the steel and restore ductility for additional processing. At the temper mill, the coil is further reduced to meet the customer's specifications for gauge, surface, and mechanical properties. This product is sold as fully processed cold-rolled. To meet today's demand for improved coated products, Severstal Dearborn invested in an exposed hot-dipped galvanizing line with advanced high-strength steel capabilities. Launched in 2011, the HDGL was designed to optimize the processing of cold-rolled coils from the adjacent PLTCM. After loading the full hard coil on the line, a high-powered cleaning system creates an extremely clean surface for the highest quality galvanized and galvannealed products. A 5-section all-radiant tube computer-controlled furnace heats and then rapidly cools strip temperature for increased steel strength across a wider thickness range. Exposed galvanized and galvanneal can be produced on the same line using a dual-pot system. The after-pot cooling tower, or APC, is the tallest in North America, providing the longer cool times necessary for advanced high-strength steel production. The skin pass mill applies a uniform texture and protects from strain lines. A hot water wash system removes very fine particles of zinc from the strip, and the tension leveler produces an extremely flat surface. An Ilux lighting and inspection system Parsatec automated inspection system and dedicated quality assurance laboratory provide for the very highest achievable product quality. The transformation from rocks to the steel used in a variety of products, from car hoods to pipe and tubing, is an amazing process. A process that has been pioneered and perfected at Severstal Dearborn for over a century. The future could not look brighter. The extensive investments and improvements demonstrate the company's unwavering commitment to its customers and to steel. With sophisticated technology and equipment to produce a broad spectrum of advanced steels, strategically located in the heart of North America's automotive manufacturing center, and with access to a multimodal transportation network, and powered by a team of highly skilled and trained steel-making experts, each empowered to safely execute today's steel-making process. Severstal Dearborn is at the forefront of a steel renaissance, changing the very landscape of steel production, reinventing a new standard in steel.